All right. So forgive me for not knowing your name and who this is, but somebody said it's too many amps. So I'm going to assume that what you mean by the amps that's flowing into the earth, you think it's going to be less than the actual 5 amps that I was saying it is. And it may be. And we're not going to put an amp meter on it to find out exactly what it is. There is a mathematical calculation. The biggest point I want to get out of all this is going to be that it's not going to be enough to cause the breaker to trip. And that's the bottom line. So the next thing I want to talk about is phases and identifying voltage and how we do it. I meant the PC crashed. Too many amps. Got it. All right. It probably is the case, but it's an Apple product and these aren't supposed to be doing that. But we'll see what happens later on. But anyway, when we determine the voltage in a house, we mostly just basically look at the wires. We don't put voltmeters on there and determine what it's going to be. So if we have 3 wires that come in there, let's start off with 2 wires. If I have 2 wires that come in there, we're going to assume the first wire is going to be the neutral conductor or the grounded conductor, and then the second wire is going to be an energized conductor. So if I have the neutral or grounded, that's going to be my 0, and if I have an energized conductor, that's going to be my 120. Now I really don't care if you say 110, 115, 120. None of that really means anything to me. Because again, we're not going to get the exact voltage that comes in there. What I do care is when we get to a single phase with 2 energized conductors that we use the proper terms. So if I have 3 wires coming in, the first wire is going to be the neutral wire again. Then I'm going to have 2 energized conductors. That 2 energized conductors then is going to be a combination system, and we're going to refer to it as either 110 220, 115 230, 120 240, whatever it is. Whatever you use on that first number, all I'm asking is that you double it. It's going to discredit yourself real quick and easy if you try to say that it's 110 240 or something like that. So just using the right terms is always best. And if we look at the picture in the diagram that's coming in there, the middle wire of those 3 wires, that's my neutral. That's my 0, all right, that comes in there. So if we take the energized conductor on the left-hand side, that's going to be at 120 volts. If I measure the difference between the neutral and that 120, or neutral and that energized conductor, I'm going to get that 120 volts. If I measure the same thing on the right side, energized conductor, and I measure that between the neutral and the energized conductor, that's still going to be 120 volts. And then when I measure between the 2 energized conductors, and this is where I get the 240 volts, that's going to go ahead and measure out. One will be positive 120, and with alternating current, it's always going to change from positive 120 to negative 120. Positive 120, negative 120. And when I show the sine wave a little bit later, because we are going to go over this a couple different times, when I show the sine wave a little bit later, you're going to see how it goes positive, negative, and it actually does that about 60 times every second, all right, and which we call a 60-second cycle, all right. So when one wire is positive, then the other wire is going to be negative, and then in between the 2 of them, that's going to be 240 volts of pressure that comes in there. One thing that I get asked a lot. Now, this breaker just has 1 switch on it. But sometimes we'll see a 2-pole breaker. And if you look at the 240 circuit on the left side, it looks like it's on the right side as well. But either one of those, we're going to have a bar that ties the 2 of those together. And let's say each one of those is 30 amps on each one of those switches or breakers. And what we don't do is we don't add them up. All right, so if it's 30 and 30, that doesn't mean that it's a 60 amp circuit. All right, same thing with our main disconnect. We don't add up however many amps are going to be flowing on there. So it's hard for me to see on this one. I'm going to guess that's, I'm just going to guess it's 100 amps, and it doesn't matter what it is. We're just going to make an assumption to that. So if it's a 100 amp circuit that comes up there, that means I'm going to allow up to 100 amps to flow on my energized conductor. I'm going to allow 100 amps to flow on the other energized conductor. And if you remember, I said amps don't disappear. So, off the cuff, I could start thinking, well, shouldn't I be sending 200 amps if they're fully loaded up there? That's not true, all right? They don't disappear, but they do cancel each other out. And that's why we can get by with 2 energized conductors and only 1 neutral. We don't have to have 2 neutrals coming back out of it. In fact, nowadays we do what we call shared neutrals on many circuits inside of a house, all right? So if I had 100 amps flowing on the right side energized conductor, and I had 0 amps flowing on the left side conductor, I will have 100 amps flowing on my neutral conductor. Since all 3 of these wires are designed to carry 100 amps, not a problem. So let's take another scenario, kind of the same. 100 amps flowing on the right side conductor and 100 amps flowing on the left side conductor. All right. That's going to, since one is positive and the other one's negative, positive 100 plus a negative 100 actually equals 0. So if they're both the same, I will not have any electricity flowing on the neutral. There's going to be some situations, such like central air conditioning heat, well pumps, electric radiant baseboard heat. Those objects, everything that's in those appliances are all 240 appliances, because of which both phases are going to be equal. You're going to see that they don't even run a neutral wire to those items because we don't need it. We only need the neutral wire in case those 2 energized conductors are different. So if I'm flowing 100 amps on the right side and I'm only flowing 50 amps on the left side, that means I'm still going to have 50 amps that's going down the neutral. I have to bring that in balance back. The first 50 will cancel each other out, and then whatever's left over will go down the neutral. So the only way that I can even get up to 100 amps is if I have 100 amps flowing on one side, 0 on the other, and that's going to allow me to have 100 amps flowing on the neutral wire. Then as soon as I start adding electricity to the left side or amperage to the left side, that brings down the neutral. They're going to cancel each other out. So, and I mentioned before about appliances such as well pumps and central air conditioning systems and electric radiant baseboard heat. Those don't require a neutral system. But let's say I hit an electric stove or electric dryer. All right, those are also 240 appliances. But with those appliances, I actually need a neutral wire. And the reason is because I'm going to end up having 120 light bulbs in there, maybe a 120 computer. So that's only going to take power off of one side. It's not going to be equal on both sides. Because it's not going to be equal on both sides, now I have to have a neutral bringing down the difference. So we're going to end up with 2 energized conductors, 1 neutral conductors, and we should have also a grounding just in case we get a phase fault or something happening there. All right. Okay. So identifying the amperage, there's a few different things that we have to look for when we're doing that. Number 1 is going to be the main breaker. All right. Now it does happen that somebody can go in there and replace a panel, and they'll use the old wires that were in existence then, and then they're going to put it on a 100 amp breaker, and then all of a sudden they're going to be advertising that we have a 100 amp service, and yet we still have a number 6 copper wire that's feeding the system, and that number 6 copper wire is only designed for 60 amps. But yet now I have a 100 amp breaker on it. That doesn't make it a 100 amp service. So there's a few things that we need to look for. I did post this chart up on my website, thehomeinspectors.com. Sorry for the cheap plug. But if you go to education and employment on there, you're going to see where determining the amperage chart is up there. So stuff that you're going to need to know is size of the main breaker, size of the service entrance cable, so the wires that are feeding us. And we go back to the chart that I wrote up earlier. You're going to need to know the rating of the disconnect panel. So that's this panel here. You're going to need to know the rating of the meter panel itself, which is going to be on the outside. Now, the problem with the meter panels, we don't have access to the inside to see the data plate. The disconnect panel, we do. So sometimes it'll be on the back door or on the dead front plate. Sometimes it'll be either on the left or the right on those things, but we do have access to them, when we're looking at this stuff. So we can see what the chart and see what they're rated for. And then we want to go whatever the weakest link out of those items are. If that main disconnect that we're looking at here is not equal to or less than everything else, then it's considered dangerous. All right. That means we're going to allow more electricity to flow through one of those items that the electricity isn't designed to carry that much. All right. Another item I left off the list is going to be our service entrance pipe and the size of that cable coming in there. I can't put too thick of wires inside of that either. So whatever our weakest link is, that's what we're going to be pointing out. All right, so meter enclosures, I'll show you a picture of those in a little bit. And in fact, let's just get right to these things. The pipe sizes, if you want to write those down, that's going to be on the chart on my website. So 3/4 inch to 1 inch is roughly about the 60 amp mark. 1 inch to 1.5 inches is going to be the 100 amps. And then once we get to 2 inches and above is where we're going to start getting to the 2-inch marks coming in there. Okay. So as we get it back into the meter enclosures, we talk about the different shapes, and we're just going to zip right through these and go back to the meter enclosures that we're seeing. All right. So these typical square boxes, they call A boxes. The panels. Now, we're not talking about the meters themselves. We're talking about the actual panel. Those are usually designed to carry somewhere around 60 to 100 amps. You're going to see these with a lot of number 2 aluminum wire service feeds coming in there. So 100 amps is pretty typical in our area. All right. These old rectangular ones with the glass in there, these again were typically 60 amps that came in there. And without getting inside of it, we're not going to know. But yeah, if you start seeing 100 amp services on these things, that means somebody changed the panel and the wires coming in there. I don't think it's necessarily the end of the world, but when, a problem is never a problem until it becomes a problem. And if these things are only rated for 60 amps and we're seeing 100 amp service coming in there, we should be calling these things out. Again, just another view, the rectangular ones with the glass front in here, these are typically for 100 amps. This one I like. It's an old round meter panel. If you had a test on this one, I would be calling it as 30 amps. You will see up to 60 amps into these systems. Sometimes they do let them be overfused in a little bit of a way, but 30 amps is going to be the magic number I want you to remember. This one is our most common one that we're going to run into. And these are typically for 100 amps. I have seen them gone up to 200 amps. But mostly the meter panel ratings for these things are going to be at 100 amps. The bigger ones, the larger rectangular ones that go into the earth, these are going to end up being for 200 amp services. They're just more common. Again, 200 amps underground coming in here. You can see how much wider the panel is and how much more area it's able to hold. All right. Let's move here. Older service meters, and we don't really see too many of these things where they say 15 on them. Those are typically going to be for up to 100 amps. This 130 is up to 200 amps. These are the old one-way meters. Everybody's switching over to the smart meters now. We just don't have these dials or clocks on there any longer. All right. Here's another one, CL, another old dial meter, one way. Sorry I don't have a picture of the newer one. I thought that was up in there.